Hello and welcome, friends. Good morning, good evening, good afternoon from wherever you are seeing this. Welcome to another session with us for maths or quants for MBA entrance exams. So, what we are trying to do today is one of the most important chapter of your arithmetic section, and that's very common in almost all the MBA entrance exams. That is average and mixture allegation. So, some of this topic or concepts I'm sure have done in your school days, but what we primarily focus on is not every formula or everything that you have done in your school, but what is more application oriented. Try to keep it specific to the relevancy of the type of questions that come in your entrance exam, be it CAT, SNAP, INMAT, IFT, or GMAT. Uh, so what we are trying to do today is trying to cover the concepts of this topic. So like we do for every chapter or every topic that we cover, we follow up with two sessions, which is two problem solving session. One is the problem solving session level one, where we do problems of level one or foundational problem to try to cement the understanding that you have on that topic, and then follow up with the advanced or level 2 or level 3 kind of problem, which has more chances to come in an exam like CAT or SAT. But for exams like NMAT, IFT, SNAP, you can see some problems from problem level 1 session also. Some of the level 1 problems can come in CAT or SAT, also depends on the luck, but these are just the probabilities that I'm talking. But what we do in this session is not the problem solving session. This is the first session of any topic, that is the foundational session, or where we cover the concepts or some formulas, some general tricks or universal shortcuts that we have, or some mm, hacks for you to understand and solve the problem. So this is the most important class which the next two class on the problems of this chapter will be based on. So we have published a lot of concepts of arithmetic till now. You can follow it. I'll put the video in the I button of the description box for the other chapters. But today's session will be on this average, mixture, and aggregation. So what we'll do in average, we will do the basics, understand how it appears, some of the scenarios. I will not say scenario specifically, some of the principles, you can say some of the principles. Then what we can do is we'll do concept of weighted average, and once this is done, then we'll move to mixture and allegation. Mixture and allegation does not have any subsections, but typically one or two concepts needs to be covered. A very doable area, you can see at least one or two problems in CAT or SAT, or in MAT SNAP IFT the problems will be 2 to 3. But this is a very, very doable area, but requires some amount of conceptual clarity, hardly any formula to remember. But if you understand it well, you will be able to solve almost all the problems from this area. So with that, let's move on. So when we do average and mixture, what do we mean? What is average? Now, let's say, and some of you may be aware of this concept, but let me make it simplify and refresh your thought process on average. So let's say there is a batsman. Let's say there is a Dravid batting. I said Dravid in year 2010. Okay, let's say going back few years, let's say Dravid in 2010, because I belong to those era of cricket when Dravid, Ganguly, Sachin, Sehwag, those era of cricket. Those are the prime times I have seen cricket being played. So let's say Dravid in 2010. Um, Possibly I've scored, let's say, 5,000 ODI runs. And let's say Kohli, who was just coming up then, scored 6,000 ODI runs. So based on this, can we say who is a better batsman, Dravid or Kohli? Okay, there are maybe uh, other situations or other variables, and people have their own uh, favorite player. But let's focus on this problem where we are trying to say who has played better in that year of 2010. So I'm not very sure whether Dravid played in 2010 or not, but my data points are not confirming me that right away. But maybe, let's say. So who is a better batsman? Now, all of you might say, okay, in that year, Kohli has scored more runs. That means Kohli is a better batsman. But that's just one way to look at it. But if you see it more, if you specifically becoming a manager or someone, you should see it from the all conclusive way. When you see a data point, you should see it, you should understand what the data is about, and then possibly you make a decision out of that and see whether the data is complete or not. Now, if I say 5,000 runs in ODI in the entire year of 2010, but if I say, let's say Dravid played only 5 ODIs in the whole year because of his injury, he was not able to play the other matches. Kohli, in the other side, let's say played 20 ODIs in the whole year. Then Kohli has played more number of matches. Kohli is being more fit or something, but that doesn't mean Dravid or Kohli is a better batsman. So how to find out who has performed better? So that's when comes the average, or we say per in per instances, average per instances. So per instances means, so there are 5 matches being played by Dravid. So for Dravid, the average is total divided by number of matches. So in this case, it will be 5,000 by 5. So Dravid on an average, we say, scored, obviously it looks a little odd, but let's say 25 matches. Okay, 25. So that means Dravid has 200 runs. Again, not an ideal one, 200 runs per match. Right? Let's say Kohli played 50 matches. So 200 runs per match is Dravid's average. Whereas Kohli's average is again total by number of match, which is 6,000 by 50, or let's say 120. So Kohli's is 120 runs per match. So I know Dravid's per match average is better, though the total runs scored by Dravid is less because he has played less number of matches. Kohli has played a lot of matches, and that's why his total score is more, but his average is less. So average basically gives you that unique or the common base on which you can compare multiple things. So unless I know the base on which someone is comparing, a full year of cricket is not enough information to have a common base. If I say 20 number of matches being played, then that can be acted as a common base to identify who has played how many matches versus who has scored how many runs. So basically, when we consider average, the most common part of calculating average is average of something is nothing but total by the number of instances. By instances, I mean in the previous scenario, it was the number of matches, and in some other cases, it will be something else. So let's say I said I scored in all the exams of math in the whole year, I have scored total 500 marks. So what is my average? So let's say there are 10 math exams in the whole year. So then my average becomes 500 by 10, or 50 marks is my average for each exam. So again, just trying to understand, average may not be exact. What do I mean by that? So average may not be exact mean in the previous example, Dravid may not have scored exact 200 runs in any of the games. Kohli may not have scored exact 120 runs in any of the games, but their average is 200 or their average is 120. That does not mean the value of the average has to be one of the values in all the matches. It can be, it may not be also. So so this is one idea. So that does not mean in any matches Dravid has scored 200 in all the matches, or Dravid has scored 200 in any match. It may be possible Dravid has not scored 200 in any of the matches. So understand that average value may not be part of the values that you are considering to find the total. So if you have considered 50 runs to find 50 innings individual runs and then find the total, in that individual runs, 200 may not be one of that. Or similarly for Kohli, 120 may not be one of that innings runs that he has scored in all the matches. It's just the average. Also, let's see few of the scenarios that we commonly face in average. So basically, let's say there are 5 students in a class. Okay, and then there is a math exam that has happened. In that math exam, let's say there is A, B, C, D, and E. Okay, A got 10, B got 20, C got 30, D got 40, and E got 50 marks. So there was a math exam of 50 marks. B being the most studious, E being the most studious students or most intelligent, got 50 out of 50. A is not so good. A needs a lot of work, so A got 10. So if this is the score of one math exam, let's say, so what is the first? Find out what is the average. So average, I know 10 plus 20 plus 30 plus 40 plus 50 divided by 5. The total is 150 divided by 5, or 30 marks is the average. So C's individual score is 30. That means the average is in the value right now, but may not be always. We'll show some other example when average 30 is not part of any of the individual value. But understand the average is of 30 marks. Now let's say scenario 1, where I say in the next math exams, everyone's scored marks is increased by 5 marks. So that is plus 5 marks for everyone. Okay. So then it becomes 15, 25, 35, 45, 55. So if you do that, everyone's score increase by 5. So what is the average score increase? So it becomes 175 by 5, or 35. So your average, this is also increased by 5. What I'm trying to say is if all the individual is increased by 5, your average is also increased by 5. Right? Similarly, if each individual's marks is decreased by 5, so decrease by 5, so then that becomes 5 plus 15 plus 25 plus 35 plus 45 divided by 5, you will get 125 by 5, or 25 is the new average, which is also decreased by 5. So if everyone's marks is decreased by 5, your average is also decreased by 5. So whatever application, same will be for multiplication, and what will happen for division will come there. But what I'm trying to say is if one of the operation, if the same operation being done on each of the individual values, the average will be impacted by the same operation as well. So if you are adding 5 to each of them, your average will increase by 5. If you subtracting 5 from each of them, your average will decrease by 5. Now let's see what happens in case of multiplication. So let's say everyone's marks is doubled now. So 20, 40, 60, 80, 100 divided by 5. So total is 180, 240, 300. 300 by 5, 60. Your average is also multiplied by 2. Right? So the same thing happening. Let's say when you divide by 5. So let's say everything is again gets halved. So 10 becomes 5, 20 becomes 10, 30 becomes 15, 40 becomes 20, 50 becomes 25. Your average becomes 30, 50, 75 divided by 5, or 15, which is also divided by 2 actually. The 30 divided by 2. So basically, again, addition, subtraction, multiplication, division, whatever you do, if you do the same thing on each of the variable, each of the individual values, your average will be impacted by the same way. Okay. Now, let's say give one more scenario. Let's say there was 5 marks codes, right? 10, 20, 30, 40, and 50. Now, if I say the first person's marks increase by 5 and the last person's marks increase by, sorry, decrease by 5. So then whether it will change your average, let's see. 20 will remain 20, 30 will remain 30, 40 will remain 40. But if you remember, what is the formula of average? The formula of average is total by n. N is the number of instances or number of observations. So here the n is 5. So, but can we see if there is a change in the total? No, right? Because 10 is increased by 5, but that is nullified by 50 being decreased by 5. So your total remains same. If your total remains same, your average will not change. So always focus on the total part. If individual values are being changing in a different way, then you have to focus on the total. If individual values are changing in the same way, for all of them, then you can apply the same thing for to your average to find the new average. But if all individual values are not changing, and even if they were changing, some of them are changing and not changing in a right way, not changing in the same way, not the right way, not changing in the same way. Like 10 is increased by 5, 50 decreased by 5. So you have to focus on the total. Is there a net change in the total? No. So if there is no net change in the total, your average will not change. Yeah. I hope things are clear. If anywhere, if you feel something is not clear, you need more clarity, you drop a comment or you can mail me in the mail ID given in the description box, and we can take it ahead and I can help you explain that. But these are very, very fundamental, seems very obvious, but try to understand the nuances of it. When you get a problem, you have to apply maybe very much logic as basic as this. But if you only focus on formulas and stuff like that, you will not be able to understand or apply these foundational concepts which are being checked heavily in exams like CAT. So understand these concepts which sometimes you may feel, okay, this is very obvious and this is about to happen, but understand how it happens, why it happens, so that you know when to apply this. So that's most important. You may get a very complex looking problem in CAT, but the nuance of solving that problem lies in understanding or applying. You may understand this, but know when to apply this kind of a scenarios, kind of an understanding, kind of this concept is most helpful and can be a solution to most of the trickiest problem of CAT. So foundational understanding or understanding in a way that you can apply that in a given problem is most important. Now let's see a little different problem. Let's say I'm saying there were 10 students in a class and their average age is, let's say, 15 years. Okay. Now I'm saying one student left, another joined, and now the average age becomes 16 years, right? Now the average age becomes 16 years. Can you find out the age of newly joined student? Age of newly joined. Basically, what I'm saying is 10 students with average age of 15 years, one student has left and another has joined. The average age, the total number of students remains same, but the average age is increased by 16 years. Sorry, 1 year becomes 16 years. What is the age of the newly joined student? Now, you can see typically there are a couple of ways to solve the problem. Let's solve the most common way. So there was 10 students, let's say x1 is the age of first student, x2 age of next student, so like that x3 till we have x10. If I divide all of this by 10, I will get the average age of 15. X10 being the age of the new, x10 being age of the student who was 10th, and possibly that guy only has left. Now, let's say the student with X10 has left, right? So, and then there is a guy with the new guy, let's say, with the age of Y. So now my average becomes X1 plus X2 plus X3. Instead of X10, now I have Y. So I had X9 there. Here I also have X9 plus Y divided by 10. This is 16. So what is changing in this equation and this equation? This equation we had, from this equation we have X10 by 10, and this equation we have Y10, Y by 10. So in this equation we had X10, in this equation we had Y, right? So can I say X10 by 10 is 1 less than Y by 10? Because the other part is all remains same. So X10 by 10 will be 1 less than Y by 10. So Y by 10 minus 1. So this is what we are looking for. Understand this very, very clearly. So X10 by 10. So if we break this, so all of this X1 to X9 remains same in both the cases. So the only change that is happening is because of the difference, that the Y has bring into the picture. So Y by 10 is increasing average marks. So what is the average marks? What is the total marks? So X10 by 10, I don't know, right? So now let's try to solve this. So if you see the problem, so what we got now is X10 by 10 equal to Y by 10 minus 1. Now we don't know the value of X10. We don't know the value of Y. So in a way, this problem cannot be solved because there are two unknown variables, right? Or what we can say is Y by 10 minus X by 10 is equal to 1, or we can say Y minus X is equal to 10. So we know the gap is of 10, but unless I know Y, unless I know X, I'll not be able to solve the problem. Now, sometime they may tell you, okay, and this is a very good scenario for data sufficiency. So if this much data is given, you will not be able to solve the problem. But let's say I said the left boy who was leaving is age of 20. So now I know my X10 is of 20. So my Y has to be age of 30. Okay, so this is the age of the new guy. But this is only possible when we know the boy who is leaving. But with this much information I have given earlier, you may not be able to solve the problem. So that's a tricky part. Always try to see what is given. Now, if the same problem is given, can we solve it with the understanding of average rather than solving it this way? This is also one way to solve the problem. Now, let's say the same problem, I'm trying to solve it in an average way. So when you are doing through average, let's say the guy who was leaving, his age is 20. So from the total, 20 is already gone, right? From the total, 20 is already gone. Now to increase average by 1, if you have to increase average by 1, that means increase each value by 1, right? So basically your total was there at the start, you have a total. After the guy left, you have total minus 20, right? You have total minus 20. Now you have to, for the new guy, now here is the new guy who has joined. Now, if the new guy has joined, then after that, your total must be increased by 10. So if you had total plus 10, because that's when the average is increased by 1, because there are 10 students. If you have average is to increase by 1, your total has to increase by 10, right? If your total has to increase by total, I mean what it was at the beginning. This is the total at the beginning. This has to increase by 10. That's when your average will be increased by 1. But when that other guy left, your total was already decreased by 20. So if your total was X, it was already X minus 20 when the guy left, but your target total or the fine after total has to be X plus 10. So the new guy has to be covering this 20 first and then add that 10. So then the new guy has to be age of 30. So basically, when a new guy joined, he has to first recover the total that the guy who has left. So that means 20. He has to recover. Then he has to give one each to each of the students so that the average increase by 1. So we have to increase the total by 10 so that everyone can increase by 1 and the average can increase by 1. So to first cover back the 20 that has gone, then he has to add back that 10 to get that 30 or find out the final total. So that's what his average has to be. He has to contribute that 10 to increase the average. He has to cover the 20 which has already lost, which has already gone. So that his age has to be 30. So this is another way where your deep understanding of average concepts comes into picture. Now let's say there is another meaning which is called as weighted average. And this and the mixture are very common. So weighted average, this is the start point of your mixture calculation. So when I say weighted average, there are a couple of type of problems. So we'll see those problems in the next minute, but let's understand the concept first. So what is weighted average versus normal average? So here, the average of two groups will be given to you, not the individual one. Like we said, individually 5 students, this is the average. No, here the group's average will be given. So let's say there is a section A in a class, and then there is a section B in a class. Section A has 10 student, section B has 20 student, right? Section A, now they said average age of each of the student is 15 years. Section B, average age of each student is 18 years. What is the average of the class? Average of the class, by the class I mean section A and section B together. What is the average of the class? So there are two components to it. So if you see, section A has number of students and the average. Section B has the number of students and the average. So these are called as weights. Weights means these are the numbers, these are the n's. The total, remember the formula of average, total by the n or number of occurrences, number of instances. So that n is basically the weights here. So number of students in each of the area, or in a mixture we'll come to that, but this is the weight. So let's say this is W1 or weight 1, this is W2, and this is your average. Now let's say the individual values. Let's say this is X1 and this is X2. So your weighted average, or we can say average of the class, is nothing but W1 X1 plus W2 X2, basically both the same, W2 X2 by X1 plus X2. So basically total by total weight, right? So W1 X1 gives me the total of section A, W2 X2 gives me the total of section B, and then X1 plus X2 gives the total number of students or the total weight. So here we have to do 10 into 15 plus 20 into 18 divided by 10 plus 20. So 150 plus 360, 510 divided by 30 or 17 years, right? So this is the formula of weighted average. Okay. So this is the formula of weighted average. So basically now if I have to generalize this formula, you can say if there are more groups than two, then it is W1 X1, X1 being the individual average of that particular group, X2 W3 X3 goes on till Wn Xn, W1 W2 till Wn. Okay, so this is the weighted average formula, generic formula. Also in another way you can see, let's say there is a weight. So think of this as a why we say weight. Think of this as a weighing machine or the balance. So there is in one end you had W1, in the other end you had W2. Okay, where the balance will lie. So W1 W1 means there were how many students? If we see the previous problem, sorry. So W1 means 10 students and W2 means 20 students. Okay, and the average was 15 and 18. So let's say there were, so W1, that means here there are 10 and here there are 20. So I know weights towards W2 is more. And W1's average is, this is 15 and this is 18. Okay, this end is 15 and let's say this is a line chart and this is 15 and this is 18. So average will lie somewhere between 15 and 18. But since the weight here is more, in W2 the weight is double, your distance of, so let's say here lies the average. And understand this is very powerful. So what I'm saying is, think of this as a balance. So this balance of 20 is double than this balance. So it will pull the average more towards, if both of them are equal, then the average will be exact midpoint of 15 on 80. Midpoint is 17.5. You can make both of them 10 and calculate, your average will become 17.5, which is the exact midway between 15 and 80. But your average here will not lie in the exact midpoint. It will lie little towards the 18 because 18 has the higher weight, so it is pulling it towards. So how much closer to 18 and how much further from 15? So if this weight is 1:2, that means then this distance will be of 2x and this distance will be of x. So distance of average from each of the end will be in reverse of their weight. So if I have to write distance of average, distance of weighted average will be in opposite ratio of the weights. Distance of weighted average from each end. Distance of weighted average from each end will be the opposite ratio of their weights. So if this ratio is 1:2, this distance will be 2x is 2x. 2x is 2x means now I know the total distance is 3. 3 is equal to 3x. So that gives me x is equal to 1. So that means this has to be 2. This point has to be 2 and this point has to be 1. So then the weighted average is no more 17.5, it is 17. 15 plus 2. Weighted average will lie 2 away from 15. Weighted average will lie 1 away from 18. Weighted average will be closer to 18. So how much closer, that ratio you can calculate based on the weight. Sometimes they will give you this distance. Let's say they have given you 17 is the average of 15 and 18, two groups individual average, and their weighted average is 17. So the weight of each of the group will be the opposite, 1:2. So you may know the distance from each of the individual to the weights to the weighted average, and use that distance to calculate the weights individually, or you know the weight earlier, like in this case you know weight is 1:2, then you can find the weighted average by calculating the total distance and divide it into the corresponding ratios like we did here. Okay, we'll solve a lot of problem on this in the next session, so that will get clarified. If there are some problem level understanding you want. Now mixture is very much same with what we did here. So let's say instead of the same problem, let's say there is a rice. You bought a rice which is of 10 kg. Instead of 10 students, rice of 10 kg with 15 rupees per kg as a price, which is nothing but the average price. Same numbers I'm using. And then you bought dal of 20 kg, which is of 18 rupees per kg. Okay. So what is the price of the mixture? So let's say you have mixed this dal and rice. What is the price of the mixture? Or what is the price of the average price, not the price, average price of the mixture, or the average price of the items that you purchase? So again, the idea is do 10 into 15 plus 20 into 18 by 10 plus 20. So this is the total, is this much divided by quantity. That's the normal way of calculating the problem. Also, the other way you can understand is rice weight is 10, and then there is dal whose weight is 20. So this is 1:2. So the distance will be 2x to x. So if this is 15, this is 18, this has to be 17. So 17 rupees per kg will be this. So this is the most common way of calculating mixture. The other way, other visual you can remember, but most of this will be solved by this. And the other visual also you can remember. Let's say higher price, or let's say higher price item, and let's say there is a lower priced item, and let's say this is the average price. Okay, so it's basically the same way, the distance that we calculate. So lower price, the average will give you the distance or the difference between average price minus lower price will give you the percentage of the quantity. So let's say this was, in my case, was 17. Then in my case it was 18, and the higher price was of 18. So 17 minus 15, it will give me the proportion of the higher price item quantity. And if I subtract a lower average price from the higher price, it will give me lower price item quantity. This is the ratio and the exact, right? Higher price item quantity is to lower price item quantity will be in the same ratio of the difference. So if I do, this is basically nothing but 17 minus 15, and this is nothing but 18 minus 17. So higher price item will be 2:1 ratio. Okay. So you can remember this visual or the visual that we have shown earlier. So distance is nothing but the difference. So that's what we are doing here. So we'll solve the problem on this so that it gets cemented. The last part of this is replacement in the mixture. So replacements are nothing but, let's say you have a 10-liter bottle which is filled with water. Okay. Now in the first instance, what you did, you take out 10% and fill with, let's say, milk. Okay. So now you have taken 10% means you have taken 1 liter out. So you have then 9 of water and 1 of milk, right? So basically you have filled with milk means you can fill only the part that is emptied. So you have taken 10%, that means you have emptied 1 liter. So that means it is filled with milk means it will be topped up by 1. So then 9 is the water, 1 was the milk. You do it again, same time, 10% of the mixture is out. Now the 10% of the mixture will not have only water because now it's a solution of milk and water. So now 10% of the water will go, 10% of the milk will go, right? So 10% of the water will go means 90% of the water remain. So that means water becomes 8.1 is water. 10% of the milk will go, that means milk will become 0.9. Then you add 1 liter because again the mixture is total mixture is still 10. No? You have taken out 10% means you have taken out 1 liter. Out of that 1 liter that you have taken out, you have 0.1 milk and 0.9 water. Right? So you will be topped up with another 1 liter of milk. So your milk becomes 0.9 plus 1, 1.19. 1.9 is the milk. So this situation continues. So basically what, and always in a replacement, if I ask what will be the case after the third iteration, how much milk, whatever being asked, how much milk, how much water, always try to work with the item that is not getting replaced. It's easy to calculate. So calculate the water here. You know the total capacity. So if you know the water, you will easily know the milk by subtracting from the total capacity. So always try to calculate the portion or the percentage of the item that is not getting replaced so that it's easy. So I know water was 100% earlier. After the first iteration, if you take out 10%, water becomes 90%. It was 9 liter. Then in the next case, water was 8.1. So then water becomes 81%. What is happening? So you are if you are taking out 10%, that means 90% remains. So 9 by 10 into 10, that gives you 9. Then from there, again, you do a 9 by 10 because you are taking 10% out, that means 90% remains. So 9 by 10 of 9. Okay. Getting it? So that becomes 8.1. Now in the third iteration, it will be 9 by 10 of 8.1. Okay? And you can calculate. So that will become 7.21 liter. 7.21 liter of water will remain. So basically what we are trying to do is, if in the third iteration, that means we will have 9 by 10 whole cube out of the 10 liter. 10 was the starting point. So 9 by 10 whole cube. So basically, you need to understand what is not getting replaced and how much of that remains after each iteration. You just have to use that number of iteration as an exponent. In this case, it's 3. And that portion of that is remains. You have to just use that exponent over that. So if 20% of the milk was getting replaced, my same equation would have become 8 by 10 whole cube into 10. Okay. So I hope it's clear. So that's it. So I hope the concept is clear. So it's basically the percentage that is remained of the item that is not getting replaced. You just have to use that proportion, and this number, this 3 will be the number of iterations. So if you want to see after 5 iteration how much remains, it will be 9 by 10 whole to the power 5 into 10 liter is basically 10 liter is the total quantity you started with. So this is the formula. And that's about it. So that is what we intended to cover in your average mixture and alligation kind of a problem. Hope this is clear. So then we can close this as of now, and in the next session we'll do the foundational problem or use some of these concepts to clarify uh, using problems, and those are the level 1 on foundational problem, and in the next subsequent session we will work on the advanced problems. So hope you understood this. If you have any doubts still here, this is a foundational area, so you may have doubts and which needs to be clarified. So please drop in a comment whether you need help or where it's not understood, or drop me an email. We can take it forward. So good luck. Happy learning. See you in the next session. Bye.